All right, howdy y'all. I'm Brian, the Senior Technical Training Specialist here at Alertus, but if you've been here longer than 2 weeks, you likely already know that. If you've been here less than 2 weeks, welcome. Open up a notepad, make yourself at home. Today, we're talking about voice over IP solutions. For today's training, we're taking a bit of a different approach. I've broken this training into 2 smaller segments. The first part is the bare bone essentials. This will work as an introduction to VoIP and what we can do with it. We've devoted a great deal of resources to VoIP endpoints over the years, and we have done a mighty fine job for ourselves, if I do say so myself. We'll cover enough information that you'll have a handle on the concepts of VoIP and their differentiating factors to competitors, but we won't go so deep as to be overwhelming, at least with any luck. The goal here is just to be familiar enough to introduce the topic and the value propositions to customers and to be able to defer to sales engineering for the more technical aspects. This is the information you will absolutely be expected to know after today. Part 2, however, is optional. This includes more technical information. It's a section I would recommend if you plan on going to any trade shows and will need to be able to discuss their capabilities with customers in person and in real time. There likely will not be a sales engineer standing next to you. The goal for that section is to prepare you to discuss what technical innovations and approaches specifically have led to our VoIP integrations. There's also valuable background information to have in general, as there's a little bit of network information we'll be covering to make it make sense. In both cases, our overall goals are going to be the same. At the end of the training, you'll be ready to explain a thing or two to our curious prospects and customers. You're not going to come away from this a sales engineer, but you should be able to know enough to move VoIP conversations forward and convey the confidence that closes deals. That means being able to clearly and concisely articulate the difference between our offerings. There are a couple tiers here. Knowing how to sell them to customers, and if you're feeling froggy, you will also be able to see what's going on under the hood. All right. Our plan to meet these goals is going to cover a lot of ground. First thing is a product overview. We'll start by establishing our baseline. What are our products and what modality do they provide? Next, we're going to examine the differences between our standard VoIP offerings and Alertus Desktop. This may seem like an odd move, but I think you will find that this recontextualization into something very familiar will help you to make things click a little bit easier when we compare and contrast them. Next, we'll go one step further and explore the SIP enunciator and how it changes, quite frankly, literally everything. After this, we'll move into our sales discussion. We'll regroup at this point for several purposes. It's a natural point for review of the information. That way we can all be on the same page. It'll concretize that knowledge by drawing comparisons based off of specific customer needs. And most important to me, it will raise any questions or misconceptions so we can follow through and hammer them out on the tech talk to follow. This, of course, does set us up for the brief tech lesson at the end on networks and VoIP. All right, enough of said jibber jabber. We're here to learn, so let's learn. Welcome to part 1 of 2, an introduction to VoIP. We offer the ability to tie into and target existing VoIP services via software integrations. These integrations will run in-house and are unique to Alertus. They allow us to utilize the native grouping and targeting from our integration partners, excuse me. This means using the Cisco Unified Call Manager, or CUCM, to target Cisco endpoints, and the Avaya push server to reach Avaya endpoints for IP Office and Aurora. These are the 2 main VoIP providers. For Cisco, it is just the one service, CUCM. For Avaya, IP Office is a simpler, smaller integration generally used for less than 1,000 users, and Aurora is used for a more robust system, generally more than 1,000 users. In all cases, we are able to integrate with them. But there is an important note there. Although we are communicating with the VoIP devices, the protocol we are using to communicate them with this integration is through multicast, not SIP. We'll discuss the significance of this further when we get into the SIP enunciation portion of the presentation. But for now, just keep in mind that although we are talking to these phones, we're talking to them in a somewhat unusual way. That's going to carry a little bit of baggage we're going to discuss. Now, when the order server does reach out to these phones, we can include in that text something that we want to display on the screen. We can stream audio, and if you're so inclined, you can also tell the phone to play a short buzz file. This is just about a second long, and it indicates that the call they're receiving is an emergency call. Additionally, I think this one's pretty neat, we can configure PIN panic presets. These are an extension that can be dialed sort of like a PIN code to trigger a preset alert. So on that VoIP service, you enter in the numbers that correspond to a given alert, and mazel tov, preset alert goes out. Now, a proprietary VoIP integrations for Cisco and Avaya require no additional hardware. But if we add hardware into the mix, things get a little bit more interesting. The SIP enunciator we'll be covering in more detail later, but for now, I just want you to keep in mind two functionalities. First, it introduces text-to-speech into the mix. This means you can use it for preset alerts with variables or custom activations rather than having to rely on the pre-recorded audio that we use for our standard integrations. Second, it does communicate using SIP protocol, which is the same standard protocol VoIP phones usually use to talk to each other. This means that we can integrate with considerably more types of phones because we're speaking a more common language. And just for completeness sake, we're also going to talk about the outbound dialing capability we have with our AVA analog phone. There's not much to say on this one, other than the fact that it allows us to outbound dial. That is to say, you can call outside to the real world using a phone line rather than VoIP. This is useful for calling emergency services if the emergency services in that municipality are cool with it. Not all of them are, so you need to check first before talking up this option. It's a neat product, but a niche. Oh, and it also supports TTS, which is, of course, text-to-speech, just like the SIP enunciator. All right, so how does VoIP differ from Alertus Desktop? At first blush, VoIP endpoints seem like they're about as far away from desktop alerts as you can get. But if you look at them critically, there's a staggering amount of overlap in functionality. That is to say, the differences are primary in the underlying technologies and their configurations. To the end user, they are extremely similar. Let me show you what I mean. All right, so on Alertus Desktop, we push formatted text to a screen, and we can include an audio file or TTS. On VoIP, we push text to the front screen of the phone, and we can include a buzz file and pre-recorded audio. If you're using SIP, you could do TTS as well. On Alertus Desktop, there's an optional feature to use a software panic button to trigger preset alerts directly from the endpoint that is the Alertus Desktop client. On VoIP phones, there's an optional feature to use a PIN number to activate preset alerts from the phone endpoint. On Alertus Desktop devices, you can intelligently target the devices by group. These are designed on the Alertus server and can be dynamically selected when sending a custom activation. On VoIP phones, the groupings already exist on the native server, such as extension call groups. So this would be on your CUCM or on your Avaya server. These can be referenced via alert services, and just like with the desktop devices, you can dynamically target, but this time using different alert services rather than different targeting groups. Same functionality, different configuration. This, however, at the bottom here is one notable difference. Alertus Desktop clients use pool architecture. This means the network load is distributed out over about 20 seconds. And there will be that 20-second variation between when the different clients receive the messages. Our VoIP integration uses what I will charitably refer to as profane sorcery. That we will be outlining in the technical portion of the presentation. This means there's a considerably higher network load because that audio is going to be streamed live everywhere all at once on the network. This is what the multicast refers to. All this to say, aside from differences in underlying network capabilities, VoIP endpoints can hit all the same value adds as the Alertus Desktop client, but there's the added bonus of not needing to reinvent the targeting groups already established on their VoIP servers. You'll need to transcribe them, but that is considerably easier than designing the paradigms from scratch. So now I've got your attention about what VoIP can do relative to Alertus Desktop. Let's take a look at what the process of getting this thing spun up looks like. All right, this is the checklist of what to expect when setting up Cisco. We'll start with confirming the customer has the minimum requirements. These are on the portal and will be in the text section of the talk, but the important bit here is about multicast mapping. We do not set up multicasting for the infrastructure of clients. We do not do that any more than we would set up their other endpoints for network hubs or switches. It's just not in our competency set, and it is not what we provide. They must have multicasting capabilities before we begin. If they have VoIP phones, though, you've got pretty good odds there. If you're wondering what multicasting is exactly, that'll be in the text section, promise. At any rate, once you know that they have the minimum specs, an implementation specialist, probably Anthony, will be sent to work some magic. This means creating a presence on their CUCM server so the Alertus server can communicate with it. Then it means setting up the Alertus server to have all the pre-recorded audio that's required and to be able to reference the buzz files that are on the phones for their particular setup. Another interesting bit here is creating this reoccurring scheduled task so that the database of phones that is being referenced on the Alertus server stays in parity with that of the CUCM server. This recurring task can be run nightly or weekly or however often the client requests it. The process for getting all of this set up, however, might be slightly complicated by a couple hiccups. If you've got multiple NIC cards, which is to say if your Alertus server has multiple separate network cards it's using to communicate, that might cause some tricksiness. But we can usually work around it. Generally, it is a discussion to have with the client just to make sure they're not doing anything exceptionally funky. I'm also paying a little bit of lip service to importing a Java key store here. If they've got an SSL certificate that's self-signed or some other wackiness, it's not a huge deal, but it is just one more thing in troubleshooting that can add to the timeline. All right, Avaya. You'll probably note there's a lot less text on this screen. That's because Avaya is pretty similar, but less complex. Rather than doing a whole bunch of rigmarole to be able to play telephone with the CUCM server, Avaya has a setting file. Just tells its phones to trust the Alertus server to begin with and take instructions directly from it. It's awfully good hospitality, really, compared to Cisco that requires you to run every communication through the CUCM server and have the phones recognize the Alertus server just for a moment to send messages. I like Avaya a lot better in case this isn't coming through. Anyway, for this integration, the Alertus server does still need to do the same installations for being able to do VoIP. You have to know what WAV files for every pre-recorded audio we want to have. And just like with Cisco, if there are multiple NIC cards, it can be a headache. Also of note, this exact same multicast mapping disclaimer. If the client does not have multicast set up for their network, we're all going to have a bad time. Make sure that is established before we begin. All right, so let's talk a little bit about this duality of VoIP phones and how the SIP enunciator is going to change the way this functions. So multicast protocol requires no additional hardware. This is what we have designed a proprietary integrations to do. It's an ancient but appropriate protocol used for streaming out data. It is fast and it goes to everything you need to. The interesting bit about this is multicast itself is going to all devices, but there is an additional protocol. And the exact mechanism for this is different between Cisco and Avaya. But the essential idea is we send it to everything, but we also tell which devices need to actively listen and all of the rest of them ignore it. So by this methodology, we are still filtering all of the information to only the groups that are targeting functionally, but on the back end of the network, it is a little bit less pretty. The trade-off is there is no hardware required, and we can do this natively with Cisco and Avaya. For SIP, you require the hardware of the SIP enunciator. Now, SIP is the protocol used to make generic calls on VoIP devices. and it allows us to target by extensions or groups. Because it's a little bit more flexible in that manner, as addition to our other endpoints, we can do Cisco, Asterisk, OpenServe, FreeSwitch, Panasonic, NCP, Mitel, 3CX, 3Comp HP, V. You can read these. The new one, though, is Vonage, which is just in the latest firmware release. So if they are not Cisco or Avaya and they want to have VoIP integration, check this list or talk with sales engineering. We're generally able to accommodate with the SIP annunciator because it is just like making a phone call inside of a VoIP network. All right, which is to say, what actually do these SIP annunciators do? So the big selling point is dynamic text-to-speech over IP. If you are using a custom activation or a preset activation, I've got a message in chat, target Cisco via unicast for just buzzfile, and then text on the screen. I believe Anthony said that that is a yes, that the multicast is a completely separate operation that is used for just the audio. But yes, you could target for the buzz and the text file. All right, there's a heads up from Kevin. All right, so SIP annunciators, what do they do? So they allow us to send text to speech over the VoIP, which for the presets or the customs, presets if they're using variables in particular, like a building or a room number, that text can be dynamically generated and sent out over the line instead of having to rely on the pre-recorded audio that we have to do without a SIP annunciator. It can be also pretty useful for, as we said, discussed, targeting the other type of VoIP phones, but the big one for me is that if you're using these SIP protocols, you are reducing your network bandwidth. You are calling over those specific lines to those specific phones, not blasting it out to everywhere and then having it filtered on the back end. Another neat thing about this is the ability to call a type of phone extension groups called a paging group. So paging groups are similar to the sorts of phone lines that we'd have, like for say tech support, where you call one number, a bunch of phones ring, one person picks up. Paging groups, you call this group and then they all automatically pick up as soon as the signal is received and start streaming the audio over the speakers. Think of like if you're in a supermarket and you hear someone being paged over the PA, same sort of idea, but using the speakerphone for the speakers or for the VoIP phones we're calling. And just to complicate things even further, the particular piece of hardware we use for these SIP annunciators can also be used to multicast as well. It's a variable that can be binarily flipped. We don't use it, but if for whatever reason we hit the impasse where they have a SIP annunciator and they decide to go back to using multicast, we can do that. It's just a strange and surreal nightmare that we support, but we support it. All right, now for the sales part of this. So from a sales perspective, our focus for supporting VoIP is for three main reasons. One, it's a defensible position. VoIP helps to enforce for our company that our customers can get the maximum utility and dependence on alertness by illustrating the value of having and expanding their network-based alerting capabilities. We can simultaneously help them with cost considerations as well as emphasize the ease and use of service through consolidating their providers, especially as customers are experiencing increased competitor noise, which is to say, we differentiate because of our enormous breadth of integrations, and VoIP is definitely one of those. We want to keep our company identity, implying that we can do so much more, and we have done a ton with VoIP. The budget is constrained. Consolidating with us can save money because we have these multiple modalities that we can target with fewer devices. Alertness VoIP is something the competitors can't do. It is a native integration for us. We own the source code, which is a sophisticated capability to create such an advanced specialization branch of tech. Would take a long time for competitors to create, particularly that PIN number integration. And Gary put in work on these endpoints. Like, how can you say no to this phase? I mean, come on, all those hours of coding, slaving away all day over an API, day in and day out, dealing with those arcane restrictions. Y'all wouldn't want to go to that waste, would you? Nah, nobody wants that. So on air value to our customers, it is something that we have significantly invested in. Not only do we own the code, but it is an internal competency. It's something that we know how to do and that we can provide for them. We're in a good place to deploy this quickly and confidently. The solution allows us to transform their phone systems into PA systems. We would use a SIP annunciator to be able to use those paging groups, but there is no like PA hardware that would need to be installed. They have the phones, it's done. We have, again, the capability to turn it into a panic button. That makes it a two-way functionality by using those PIN codes. Depending on how the multicast is set up, we can avoid network latency and congestion from the other providers that uses mass dialing, because instead of dialing a million numbers and individually sending it to them, we are just blanketing out. So we do have the network cost of it going over all the specific means of communication, all of the network, but we don't have the congestion of individually targeting and sending all of that information as well. And particularly important is that VoIP gives us the opportunity to unlock the software versus hardware issues that are coming up as supply chains we get a little bit more congested in 2022. They have already existing hardware endpoints that we can target. That puts us a cut above other competitors that would require any sort of hardware endpoints to be built. We know some customers have moved away from having VoIP as their primary set, but even if we can capture 1 of 3 customers, we could see potential candidate numbers in the hundreds. All right. Before we move on, I would want to open up the floor for any objections, anything that salespeople have seen as issues to integrating with VoIP, so we can briefly discuss ways to kind of work around this, things that are typical issues that get risen when we talk about VoIP. Or is it just that easy?
Guys, this is a very important time to flag some of those objections. VoIP is something that Jason is really prioritizing for us to push. I'm sure that your directors have, already illustrated that to you. But if there are technical objections that you guys are coming up against or anything else, now would be a good time to talk about them. I'm sure that other people may have had objections as well, but maybe they haven't had the objections that you've received. And maybe this is a good place for other people to provide their feedback.
So Kevin in the chat says, customers say Rave already does this. Does have you SIP or mass dialing? So as far as I understand it, the Rave integration, as it was messaged in the sales question answered, does not allow them to do the paging groups that allow it to come over the PA systems. And it seems Kevin's alluding to a mass dialing, which would be separate from a proprietary solution, which is the multicast, which does not cause the mass dialing to go over the network. Thank you for the alley-oop from Kevin. That makes it a lot easier to talk to our selling points. Sort of a softball there, but I appreciate it. Is there anyone else with objections or issues or just things they want to air? Because we got a lot of smart people on this call. No pressure or anything. No? All right. So that is the end of part 1 of this discussion. We are going to be moving into the more technical section following this. It has been simplified a little bit from the full bailiwick that Anthony has provided me, but I do want it to be something that we can kind of discuss and walk through. So if you would like to get to the rest of your day at this point, you are more than welcome to leave and progress to whatever else you need to get done. if you're interested in getting the information that would be a little bit more valuable for floor shows and for being able to talk more directly about where competencies lie and how they're created, then I would recommend you stick around and learn a little bit more tech information. Give people a second to leave here if they want to, and then let's move on. VoIP Part 2, a deeper dive. All right, so as messaged at the earlier, we're looking at the base requirements here. This is on the portal, but we're going to go into a little bit deeper here. The server requirements for Cisco are nothing particularly wild. I mean, server 2008 or later, I think we can handle that. We are able to handle CUCM from 9.x to 12.x, which is to say the current versions of CUCM. You can see our device models also go way back to the 6000 models. Like, we're pretty good on this. You do want to have a decent server. 16 gigabytes of RAM, 16 gigabytes of RAM is not unreasonable to ask, but it is just good to know that it is a decent size server if we're working with VoIP. Also of note is that the CUSIM and the Alerta server should be in the same network, easily routable to each other. I don't want to do any sort of hamachi nonsense. The easiest thing you can do here is just have them be the same server, have it use internal ports. If that's not possible though, keeping them on the same server is sufficient. Avaya, also not too extreme. You'll note the exact same hardware requirements, same software requirements. It's just easier to work with. For text alert and multicast audio, we have slightly different sets of applicable models, but I'm not going to go over the specifics of these. Just look it up on the chart. It's a lot easier than trying to memorize them or make logic apply to it. And just like Cisco, keep stuff in the same network. That way we can actually target it. Same with the ports. Fun stuff here gets into the technical parts. All right, what factors went into determining what phone models we can and can't work with? Charles working in a lab and seeing what we can make happen and what we can't. It's a combination of hardware and firmware, and there is a little bit of arcane alchemy there. So you might have noticed a year or two back, we introduced the VoIP phone report to the list of reports on the Alerta server. You may have also noticed that some of the messages there are kind of weird. That's because different versions of firmware use the exact same character codes like F or S to represent separate states from different versions of the same models on different firmware. It is kind of a nightmare. It is as much of a Wild West as fire panels. So we're really just working with what makes sense within that kind of frontier architecture. I wish I had a better answer for you, man. Really do.
That's fine. Thanks.
Yeah, you're good. Okay, so to better understand what's going on with this multicast, we have to understand a brief history lesson of how networks were designed, because it's going to make this make a lot more sense. The easiest way to think of this is like the transit system in London. There are some roads that have origins well before the Romans came then and have been transformed radically since. And there are additional forms of transportation that have been introduced over time: pedestrian, bike, bus and subway. Different purposes, but handle traffic differently. Similarly, on air actual digital networks, the design was also iteratively cobbled together without an overarching plan, and it really shows. So the crib notes of what this looks like is that we've got multicast, UDP, and TCP. Multicast is yelling indiscriminately into the void. You say, everyone, here's a message. And this is the primary tech that's going to be used for air interactions with sending out messages. UDP is similar to multicast, but you add addressing to it. So you're still shouting into the void, but in a very specific direction. TCP is what we use for almost all communication nowadays. It's why you've got that little lock on the websites. It is why we have responses to devices, and it's because we have a little conversation that's conventionally called a handshake between the credentials of the devices communicating. It is also considerably slower. So if you're trying to say stream audio, it would not be a good idea. And as such, we rely back on the very old technologies of the days of yore. So to make sense of that, we're going to take a look at what it does on the back end so that we understand how the filtering works. So back in the day, we have these computers and they have a hub rather than a switch. A hub cannot address. So we have a computer wants to talk to another computer. Let's go ahead and correct that. That's a better representation of the intelligence of this device. So how it works is a message goes up, then it gets sent to everyone, and the one that has the intended target receives the message and knows that it is supposed to have it. The rest ignore it. Just to say, message says, this is for this computer, and if you're not that computer, you don't care. So this is good, but as networks expand, now instead of 3 computers ignoring this message, we can see that we're going to have significantly more issues with air bandwidth. So we go up to a hub, it goes to the next hub, and we've got a lot of traffic. That is unnecessary. Now, if you imagine this spanning out into what conventional networks look like, we've got issues. This is what spanning tree protocol was designed for, and that's why we do not have these infinite loops. Side note, alert beacons do not work with spanning tree protocol, which is why we need a little bit more intelligent network devices here. So this is a more accurate representation of what we have nowadays. We've got smarter routers that can be configured for multicasting. Again, this is the part that we do not do in-house. So the client we're talking to has to have already programmed these network switches now, instead of hubs, that are able to direct traffic to know how to multicast. Good note here from Avi that the advantage of TCP is that information delivery is guaranteed. Because we have that handshake, we do get the report back. Whereas with UDP, it is just shouting in a direction we don't know if it's received or not. It is one of the reasons why this is so much faster, because we're not waiting for a reply. Much like giving a training where no one will answer if there are any questions. Much faster. All right. So in this framework, we're now looking at UDP. So we know which device that we're trying to reach. We have the direction, it is intentional, it is targeted. And if we add the back compatibility or the back messaging, as Avi mentioned, this is the difference from TCP. We have a communication that goes back along the lines. Let me go back for just a second. So to make this clear, when we are using TCP, which is going to be part of the pipeline we talk about with these VoIP phones, there is this handshake and understanding. When we use multicast, there is not. So there's going to be multiple communications happening simultaneously when we do VoIP alerting. The Avaya flow is much easier. We're going to start with that. So on the Avaya server, there is a file called 46xx setting.txt. These X's don't get substituted for anything. It's literally just 2 X's. I don't know why. That is the file. And that file is located on the file server for Aurora or just on the IP Office server for IP Office. In both cases, when you make changes to this file, it doesn't update automatically. So you need to either tell it to push or just restart your phones. When the phone restarts, it regrabs that phone or regrabs that file. Once the phone has that file, it knows that it can trust Alertus, and anything Alertus says is just fine by them. So then Alertus sends the messages over port 8280, including a message, a buzz file, and audio files. This one will need to be updated here. I apologize. This is a little bit outdated on this section. The audio file is multicast. So let me make a note of that. The phone responds with the success and failure options. This is the part that responds to the 8280. That's the TCP communication, whereas the audio file, again, is multicast. To quote Eliza, what I'm saying, not what I'm doing. Perfect. All right. So those success and failure messages then put onto the VoIP activation report. Of important note here is that Avaya charges for tech support assistance. So if you were tasked with setting these things up, you might want to check with us in-house first before calling out of house. Just a heads up. Cisco, by contrast, is a literal nightmare. So first thing you need to know is that rather than just being cool with the Cisco phones, the database is imported through an API. The API for CUCM is called AXL because we don't have enough acronyms already. This uses 8443. So once we have that existing communication and it's assumed that it is up to date, we know what phones are what, we can then use our service credentials on the CUCM to connect over 2848. So we as Alertus contact the CUCM server and say, I am a service user and these are the things I would like to do. This tells the CUCM server to push information out to the phones. The phones then reach out from the phone to the Alertus server via our SOAP API, which is 8280, and ask, what's the message? Is there a buzz file? And are also permitted to then receive multicast. So it is the CUCM communicating, or we communicate with the CUCM to initiate the TCP connection. This is where we get the information as to whether or not those phones are active or not. So that's when we get our success failure messages. This is separate from the multicast that's happening at the same time. The multicast is what carries the audio. So we get the message about whether or not the message in the buzz file played, and that gets stored on the VoIP activation report. The actual audio file then gets streamed out simultaneously, but is not recorded here because, again, it is not waiting for any sort of a receipt. It's using multicast, not TCP. All right, so that is the technical rigmarole. Hopefully it is not too complicated or overly stressful, but if you have any questions on the flow of Avaya or Cisco, this is a great time for it. It is still very fresh in my mind, and I would be more than happy to talk at length and in detail about anything you'd want to know. If not, this is being recorded, so you'll be able to reference this brief speech and be able to use it for your own knowledge when working with customers. All right. Now, for real, we are done with the training for today. I hope there was something useful for all of y'all. And as always, if you have any questions, feel free to hit me up. My Google chat is always open, and as is my email. I hope you all have a wonderful rest of your Friday, and I will talk to you during the next training.
Appreciate the training, Brian.
Thank
Thank you so much.
Thank you, Brian.
Oh, my pleasure.
Sorry for interrupting with my notes.
No, man, it's good to be able to echo back and make sure the distinctions are solid.
Yeah, I already start typing the 4 steps for the handshake, but I said, nah, no need to.
I would love to do a generic networking one at some point in the future. It's just such a huge backlog, you know?
Yeah. Okay. Have a good one.
You too, man.